Very warm hello and welcome to the first knowledge exchange workshop of the BioRural project. So it's really an honor and privilege to host this meeting. My name is 𝐒𝐿𝐼 𝐿𝐼. I'm coming from the University of Ljubljana, and actually the University of Ljubljana is responsible, culpable for everything that happens in the next 3 days of these intensive workshops that we have. First of all, please let me allow few words about the project, under which this workshop is taking place, and moreover about this workshop, which is the first in a row of 5 such events, and then also about the structure of the workshop. First of all, as mentioned, BioRural is a Horizon Europe project. It's a CSA project, so it is about communication of let's say socially burning issue, and it is a partnership of 19 institutions from 14 countries, which we have divided into 4 macro regions. And the core challenge that the problem is tackling is, and let's say also the niche in between number of projects dealing now with awareness raising of the opportunities of bioeconomy, is that this project is focused onto small scale solutions that are that fit ideally to rural actors. So it is also our target audience of this chain of webinars that we are showing the possibilities, showing the good cases, and also some things which are cross-cutting important when we commercialize bio-based solutions. I will not go in deep into the project, no worry. I would just like to show that this workshop is a part of, let's say, the first pillar dealing with knowledge exchange on bioeconomy, while we are also having a strong networking activity within the project. We are establishing something that we call European Rural Bioeconomy Network, connecting together stakeholders all over Europe. So you are most welcome to browse in the through the web page of the project and see what the network offers. And we should come out also with some blueprints for business models on 5 main bioeconomy themes, dealing with forestry biomass, agri-food biomass, with bioenergy, with biochemicals. So it's that are the leading themes, and aquatic biomass I forgot. Sorry for that, Maya. Anyway, these are that's very shortly about the project. We will be glad if you follow our following activities as well. But I will now focus to the set of workshops which I announced already. So the meeting in which we are in today is on biochemicals and biomaterials, which will be followed by one dealing with aquatic biomass. Here it is a company, Slovenian company, 𝐒𝐿𝐼, being responsible for organizing the whole event. Then it is this is followed then in February by a webinar on agriculture and food systems, so on circular use, on more efficient use of residual biomass from this source. Followed by, yes, this one is run by 𝐒𝐢𝐿, by the Polish State Institute for plant production. The forestry and habitats workshop is then in March, co-organized by Latvian University of Life Sciences and University of Coimbra, Portuguese. And the last one is on bioenergy, which will be organized by our coordinator, CERT, Center for Research and Technology from Greece, together with the University of Coimbra. I hope you will like and find useful this first workshop, and that we really warmly invite you to also be a part of the following 4. All those workshops will run in the same manner. So it is quite intensive gathering, lasting for between 1.5 hours and 2 hours. In the first day, we learn about the basic concepts, technological properties or principles, which are needed to have a better knowledge about valorization of biomass streams. That the second day is, let's say, quite motivational, speaking about the good practices, about factors of success. We'll be meeting actors that have actually successfully commercialized their solutions. So the third day will be about cross-cutting themes, about themes which we should think, but usually this is not the case. So we have a set of very capable presenters on this as well. So of course, the 2 hours, 3 days is just for us to convey the first information, to inspire, to encourage, to motivate for your further use, so that we can together develop rural bio-based success stories. That was the introduction from my side. And now, finally, the main thing starts. So we are starting with 3 sources of biomass, which are entering into our value chains in rural areas. And for the first one, we have, since, well, we took the privilege of Slovenians, for us, woody biomass would be the most obvious biomass source to start with. So we are doing that exactly. And we have with us Primož Oven. Professor Primož Oven is head of the chair of wood chemistry from our university. So I think we are in safe hands. So I'm passing the word to you, Primož.
Luca, thank you for a nice introduction. Distinguished audience, I will talk about biomass side streams in forestry and wood processing, as already said. All contributions just a second. Yeah. All contributions within this webinar are placed in the concept of circular bioeconomy and the project. We must not forget that the concept of circular bioeconomy is actually a systemic response and an alternative to the existing linear economy, which has brought society to the point where we face negative climate and environmental records on a daily basis. A report of the European Court of Auditors published in July stated that, quotation, although EU funds and general support for the circular economy have been available, the Commission and Member States have not successfully channeled the funds into investments focusing on the circular design of products and production processes. EU funds were mainly spent on waste management, which has less potential to reduce the impact on the environment. End of the quotation. We hope that with the activities within this project, we'll be able to contribute to the accelerated integration of bio-based solutions not only in rural areas but broader. Hence, we will focus first on basic concept regarding biomass from forestry and wood industry. I will discuss briefly the structure with basic wood properties and chemistry of woody biomass. We'll mention biorefining, and finally I will discuss cascading valorization of biomass through the production of extractives and nanocellulose, and we'll try to wrap up on time. So, origin of biomass is our first topic. Biomass, as you probably know, is defined as matter produced by living or until recently living organisms, excluding those stored in geological formations. Majority of biomass on the planet is produced by plants, as you can see, about 70% of it by trees. Primary biomass is originating from forestry, from agriculture and food sector and aquatic system. Secondary biomass is formed during the processing, conversion of biomass, decomposition of organic matter and other, as well as from municipal community and producing municipal waste. Presentations on agriculture and biomass and biomass from aquatic systems will follow later in the day, so I kindly announce this. So the total living above ground biomass stock in EU forests estimated for the year 2020 is equal to 18.4 billion tons of dry matter. This value includes above ground biomass of the living trees. The countries with the largest biomass stock are mostly located in Central Europe and in the north of Europe, in Finno-Scandia. Wood in forests consists of living and dead wood. Above ground living biomass is all biomass of living vegetation, or both of wood and herbaceous. Woody biomass includes stems, stumps, branches, bark, seeds, and foliage. Dead wood also represents woody biomass. It includes standing dead trees or wood lying on the surface of dead roots and stumps. The most important source of woody biomass is roundwood, which includes wood of any quality. Another important forestry category is industrial roundwood, which excludes wood for fuel. Another one is industrial wood, which includes roundwood used for poles, piling, among others for tanning, distillation, and so on. Another important source of woody biomass is wood processing industry. In addition to wood sortiments, it is producing wood residues, which include sawmills, rejects, slabs, edgings and trimmings, veneer log cores, veneer rejects, sawdust, residues from carpentry and joinery production, wood residues that will be used for production of pellets. Woody biomass supply chains include the provision of primary wood from forests and other woodland, industrial byproducts of wood processing industry, pulp and paper industry, and post-consumer wood or used wood. In this rather complex Sankey diagram of biomass flows in forestry-based bioeconomy, I would like you to concentrate on colors rather on the numbers. So the green arrows represent flows of roundwood with bark. The darkest green arrow above represent bark, which you can see is immediately used for burning, for energy. Lightest green shows flows of roundwood. Orange arrows represent the flows of all kinds of industrial byproducts. Dark purple arrows are for the paper and paperboard products, while light purple for the recovered paper. Yellow arrows represent post-consumer wood and red semi-finished wood products, while blue represents wood flows of wood used for energy production. Wood and biomass are versatile materials and can be used for different purposes due to its properties. And it is very important to consider and to know something about it. So we will consider first structure of woody biomass. Wood is botanically secondary xylem, which means it is formed by vascular cambium annually in our climatic region, approximately between April and mid-April and beginning of August. High quality wood and structure of side streams like so and so on have similar structure originating actually from the anatomical features of wood. Topography of different tissues and the cross-section of the stem are presented on this figure, and apparent is hardwood. Hardwood formation is typical for many species like oaks, elms, pines, larches, and so on, which all have colored hardwood, being extremely rich in extractives. Spruce and silver fir, for instance, have uncolored hardwood, while others, some species does not form hardwood like beech, where we can found discolored wood. Color change in this case is of traumatic origin and differs from the properties of hardwood. Woody biomass and low quality woody biomass are usually characterized by a different growth and technological defects. Some among these are listed here, and these are spruce affected by bark beetles, for instance, knots, reaction wood, already mentioned, discolored wood, and abiotic and biotic damage, which is very frequent in the last decade in the wood. All this exceptional material differs from basic properties. Wood is composed of cells, and here you can see a basic composition of softwoods and hardwoods. So we cannot go deeper in this, but some basic properties of wood are originating from their anatomical structure. For instance, density, which can vary from, let's say, in conifers, 430 to 750 kilograms per cubic meter. Wood can be considered as chemical product of trees and is technically defined as polymer composed of cellulose, lignin, and hemicelluloses. All these compounds are very interesting macromolecules for production of different bio-based products, and this will be discussed later during the day. Extractives are non-structural compounds found in wood in different parts of the tree. And extractives are usually defined as compounds soluble in polar and non-polar solvents and water, and are classified like lipophilic and hydrophilic extractives. They have specific function in tree and great variability regarding distribution, and this table for Scots pine reveals that. I must say that extractives are low volume, high value bio-based compounds. Woody biomass is a superb feedstock for biorefining and production of various bio-based products like feed, food, chemicals, materials, and bioenergy. Biorefining deserves special consideration. I would like to pay your attention to another two presentations that will follow toward the end of today's webinar, and will be dedicated to biorefining. Woody biomass is highly versatile material and can be used and reused in cascade in different processes. We'll discuss the concept of cascading use of low-quality woody biomass, residues from forestry operations, and residues from wood processing industry for production of extractives and nanocellulose. Selection of feedstock is important step in extractive value chains because it essentially defines what will be our final product. It has been demonstrated that salvaged woody biomass and dead wood biomass that have been lying on the floor for months or even years can be successfully employed for extracting bioactive compounds. Quality and quantity of extracts depends on extraction technique and solvents used as well. First product is crude extract, which can be in some cases already used and have applicative value, but it can be further processed, concentrated, separated, and purified in order to isolate individual compounds with certain applications. Application of wood extractives is versatile. They can be used in enology, used for adhesives, and so on. They were successfully applied in wood protecting formulations, in functional materials, and in food additives. Here as well, I would like to invite you to tomorrow's webinar. A company, Ars Pharma, will discuss their value chain based on the production of extractives from silver fir bark, and it will be definitely something not to miss. So nanocellulose is another interesting product from woody biomass. It is produced from woody biomass already free of precious extractives. Nanocellulose can be produced from different lignocellulosic feedstock, woody biomass, agricultural residues, even from invasive alien plants, as well as from chemical and mechanical pulp. Two main types of nanocellulose are nanocrystals, cellulose nanocrystals, and cellulose nanofibrils. They essentially differ in their morphology and consequently in their applicability as well. The cellulose nanofibrils are usually up to 60 nanometers in diameter, approximately 1 micrometer or few micrometers in length. Nanocellulose has exceptionally good properties and can be used for development of new materials or for improvement of properties of existing ones. Nanocellulose was applied for production of different bio-nanocomposites of casted films and extruded composites. Mainly nanocellulose was here used mainly as reinforcing component. It was used for development of hydrogels aimed for medical applications and aerogels. Some of them are showed in the slide, and all of them are supported with the research publications, although only few are listed here. I would like to let you think about the conclusion that nanocellulose represent high-tech material obtained from woody biomass with practically unlimited application. I would like to end with following very simple 3 conclusions, take-home messages. Woody biomass is renewable and highly versatile feedstock. It can be used and reused in different cascading processes. In addition to traditional processing of wood, woody biomass has high potential for diversified, small-scale biorefining processes, even in rural areas. At this point, I would like to thank you for the attention, and I'm giving the word back to you, Luca.